Okay. Okay. Today I hope is the last day or the last session of chapter 8, looking at working with triggers and transactions. Last time we did spend some time looking at transactions, and today I want to continue from there. Okay, so last time we ended at looking at this example of how to revert transactions. Today, I want to, before I continue, I want to look at the request that Messi made. So you can revert transactions manually, but there is also an option which we can use to allow for transactions to be reverted in the event that an error has occurred during execution. Okay, so I do have one transaction here. This transaction I would want maybe it's a long one, so I'd want maybe some parts to be reversed automatically. But for the others, I may want to determine. So I can use a statement, this statement, set exact abort or on. That's the statement that is used to allow or disable SQL Server to revert transactions. When you set it on, then you are enabling SQL Server to be able to reverse the transaction if an error occurs. So I've used both in this example. I've used both first of all, we start by ensuring that if there is a table that is already created called T2 is deleted. So we have used the if statement to check that the object that is a table named T2 exists or does not exist. This statement is saying if there's an object with an object ID corresponding to N2, T2, when you see something like this, what does that mean? When you see N followed by something in quotation marks, what does that mean? Or when you see N appearing in front of data type, what does that say to you? Okay. When we use N in this way, we are saying this, what follows, might be of a Unicode data type. Okay, it might be of a Unicode data type. I'm sure you recall that for the data types, we do have Chap, varchar, but we also have N Chap and N varchar. Okay, so these, they include Unicode. These are for Unicode. Next, what do we mean by Unicode? That is Unicode. Unicode, we said that this is the data, this is a case where we want to extend our set of characters from the typical standard characters, which are about 256, to include special characters, like those which are used in French. In French, you have letters like E, they have the thing on top and so on. Those are not covered in the standard character set. But if you're going to design and develop the database that will be used in a multilingual setup, then you may have to take that into account. So for such type of databases, instead of using varchar, you use nvarchar. Okay. All right. So Okay, so this first part is checking if there's an ID, object with an ID N2. If there's no object, it's checking that if this is returning a null value, it's not returning something. It means that there's a table which has been given, which has been created, which is existing. And when that is true, then the first thing is to drop the table. But if there's no, this returns a null value, then this is ignored and straight it will go to this part. Again, it will check for the object ID named T1. If it doesn't exist, then this part is ignored and it will proceed to that. If it does exist, that table first is deleted. The idea is when we execute this part, we don't want to get an error message saying the table already exists. So this set of statements have to be executed every time. If the table has already been created, if those two tables have been created, they'll be deleted before you reach this point. Then in this table called T1, we are inserting the values 1, 3, 4, and 6. Then we set the exact abort off. Then we begin the transaction here, which will give a foreign key error. Why would it give a foreign key error here? We're inserting data into the second table. The foreign key will require that this value should exist in the primary table. And if you look at that, you see that there is no value corresponding to 2. Okay, so that should give an error. Okay, and next we got to commit transaction. After that, we set the exact abort to on, and we begin the transaction. This time, in table 2, we insert values 4, 5, and 6. 5 is not in the first table, so it's supposed to give an error message. So this is going to be reversed. Okay. And so what is going to happen is that when we've tried to view information in the second table, we are going to have this one, that one, and which other value is going to be there? 2 is not going to be there. That is going to be reversed. Okay. You're welcome. Okay. The key 5, insert error with exact abort on caused, or the second transaction rolls back. It's going to roll back. This one, the first part, which is this part, there will be an error, but this one will succeed and that one will succeed. But because the rollback is not enabled automatically for this part, those two records are going to be added to the table. Are we together? Okay. Okay. But here we have set the exact abort on, meaning that if something, an error occurs in this transaction which is about to begin, everything has to be reversed. Although when you start the transaction, this part is going to be successful. Sorry, not this part. There's, let me see. Yeah, there is 4, 6. So that is going to be successful. Data insert will be successful, but this one will fail. But because we have set exact abort on, all the 3 insert statements are going to be reversed. In which case, we are only going to remain with this one and that one. Okay. And the last part is doing a select so that we can view the results of our statement. Okay, so we get some statements here about foreign key constraints being violated and so on. If we go to results, we see that in table T2, we only have 2 items. The row where there is 1 and where there is 3. Meaning that this one, where we tried to insert 2, failed, okay? So that's just an option that you can set to reverse transactions automatically. Mercy, is that okay? This was your question. Okay, what is not okay? You had requested for an explanation of this after I made a point that rollback, when you are doing transaction, and an error occurs, if you don't implement the rollback in your code, the changes are not going to be reversed. But when you use the exact abort on, then you're saying, if an error occurs, you want SQL Server to reverse, to roll back the transaction. Yeah. Okay. So now, today I want to look at implementing transactional integrity. Remember, SQL Server is the database software that is used in a multi-user environment. Okay. SQL Server is not like Microsoft Access. Microsoft Access is a desktop database software where only one person will use it at a time. But SQL Server is supposed to be used in a corporate environment where you're going to have a lot of people doing transactions or performing transactions on the server. And chances are that at some point, there may be cases where two users may need to access two resources at the same time. Okay. In a multi-user database environment, users can access the database at any single point in time. It could be that you have implemented maybe a human resource application, or it could be that you are using SQL Server as a backend for an online, an e-commerce website. Recently, the investor launched a service like where students can apply online. Okay, you don't know when those students are going to attempt to apply. Okay, and so the possibility of more than one user attempting to access the same resource, like a table, at the same time are going to be there. Okay. Users can also execute, update, delete, and or select statements on the same piece of information. You have designed a payroll system, and during today is the last day of before you close the payroll and prepare the pay slips. So you might have more than one accountant working. This accountant will be trying to maybe increase the salary scale of one employee. Another accountant may be trying to make changes to the salary scale of the same employee, or maybe not the salary scale, but maybe trying to there's some allowance due to that employee. So you find that two users are trying to access the same record at the same time. So what happens? That is what often leads to loss of integrity. Okay. Both of these scenarios can lead to errors and inconsistencies in the data stored in the database. SQL Server uses the concept of locking to ensure transactional integrity. We have looked at integrity at different levels. We have looked at integrity at table level, where we say that you can use constraints. In the previous example I showed you, what was at work was a constraint, foreign key constraint, which required that before you insert a value in the secondary table, there should be a value which matches what you're inserting in the primary key. Okay. But this is another level. Here we are trying to ensure that especially for cases where you are dealing with multiple tables. You can update data and ensure that the data maintains its integrity by means of locks. SQL Server implements locking automatically, but allows you to explicitly use them in certain situations. Again, this will answer the question that Gift asked about why, when I was giving an illustration on a transaction, the first time, the second query was kept pending until we had committed data in the first transaction. But the next time, while the first transaction had not yet committed data, the second query was able to produce some results. This will be able to explain how that happens. Okay. So SQL Server implements logs automatically, but you can manually set logs for particular instances. Why do we need locking mechanism? What problems does locking seek to address? Problems that might occur if more than one transaction uses the same data include the following. There is loss of data. There may be loss of data. There might be what is called uncommitted dependence. There might be inconsistent analysis, and there might be phantom reads. The first one is lost updates. Lost updates occurs when two or more transactions try to modify the same row. In this case, each transaction is unaware of the other transaction. The last update in the transaction queue overrides the updates made by the previous transaction. This leads to loss of data manipulation performed by the previous transaction. Here is an example. In a banking application, two transactions are simultaneously trying to update the balance details of a particular account. Both transactions select data from the table simultaneously and get the same value for the current balance. So for example, if it's my account number 0123, then both transactions find that I only have 250 kwacha in my account. Okay. Now, remember, a transaction is a series of statements, which will start with begin transact and will end with commit transact or rollback transact. So the first statement in that transaction will be maybe a select statement with a condition to find that account. And the results are going to be fed used in the next statement. When one transaction is committed, the first transaction to be committed, the balance, suppose I've received a payment of 500 kwacha for teaching NIIT but at the same time, I've bought a laptop online. So they need to deduct $450 from my account, equivalent, okay? So the first transaction to be committed is going to update. So if it's the payment, it's going to add 250 plus 500 and make it 750 kwacha. But remember, for the online payment, I need to be charged the equivalent, kwacha equivalent of maybe $450. So when the transaction started, it observed that my balance was 250 kwacha. But because the first payment has been committed first, my balance has changed to 750 kwacha. When the second transaction tried to update, it's going to update 250 minus the equivalent of $450. So what is going to happen is that at the end of both transactions, the payment which was made of 500 would not reflect at all. And that's what we're saying, lost update. Yes,
I also experienced a situation where I was paying for the project. So I wasn't know for money.
okay.
That put in my account, but if the transaction did not reach costing. So yes, I don't know where it ended from, but I want to go to check whether I know how should be not the what we do yes like or maybe did they send back the message that what was successful and I know but if the message is saying it's just successful, but that night it did not reach. Even MTN did not know where it ended. So I think this one has explained that
Yes. So what would happen is if you only have, you're paying for, maybe you're paying 400 kwacha and you only have 700 kwacha. When you first make the attempt, 400 will be deducted. The first transaction is going to show that, see, you have now a balance of 300 kwacha. When another transaction tried to commit, it's going to try and to assume that you still have 700 kwacha. Okay. So this is what is referred to as lost updates. And if the person who has designed the website has not taken this into account, this can lead to costly inconsistencies and errors in your data. And please remember, some of these issues have got legal implications. So you have to be very, very careful. Okay, so that's the first one, lost update. The second is uncommitted dependency. This is also called a dirty read. Okay, it's also known as dirty read. This problem occurs when a transaction queries data from a table when the other transaction is in the process of modifying the data. For example, the details of all the products are stored in a products table in a database. A user is executing a query to update the price of all the products. While the changes are being made, another user generates a report from the same table and distributes it to the intended audience, maybe the manager or supervisor. The query finally commits and the table is updated now. In this case, the distributed report contains data that no longer exists and should be treated as redundant. I'm sure you may have encountered a situation where you go to Lusaka Water and Storage, you make payment for the water. When you get home in the evening, you find that all those people from Lusaka Water and Storage came and disconnected the water. But I've already paid. That is because maybe the report was being generated before the transaction, which was for the payment, was committed. So there was that inconsistency in the data. Inconsistent analysis. This is also known as non-repeatable problem. The problem occurs when a transaction queries data from a table when the other transaction is in the process of modifying data. The problem arises when the data is changed between simultaneous read by one user. An example make it clear. A user generates a report to display the balance of all accounts. The user uses the result to set update data. No, you have you use a select statement to retrieve, and you use that as a sub-query in another query to update. Okay. Number 3, then the user again retrieves the result set to reflect the changes. Between the execution of the two queries, another user updated the original table. So that is going to result in inconsistent analysis. The last one of the errors or why there is need for locking is phantom read. Phantom, what does the word mean? Phantom. A ghost, okay? We're talking about something that is not real, okay? Or something that appears, but it's not really there, okay? So the problem occurs when new records are inserted by a user are identified by transactions that start prior to the insert statement. For example, in a ticket reservation application, a user called Ben starts a transaction and queries the available seats. The query returns a value of X seats available. Then the transaction tries to reserve all the X seats. Simultaneously, another user, Sarah, reserves X minus 2 seats. So if there were 10, Sarah has reserved 8, and there are only 2 remaining. When the transaction of Ben tries to reserve 10 seats, the required number of seats is not available. They get an error message saying there are not enough seats available. What has happened? It's because while the transaction was being executed, an update or insert was made, which changed the data available. Okay. So phantom read is when statements by one user or statements in one transaction get two different readings because another user or another transaction had performed an insert or update statement before the data was committed. So we have just been looking at why we need locking mechanism in a database. Okay. Now, SQL Server implements a multi-granular locking, which allows transactions to lock different types of resources at different levels. Multi-granular. This term is taken from grain. In other words, SQL Server implements a very refined type of locking mechanism. Okay, it's not just locking at the database level, but you can lock at table level. You can also lock at the level of the rows, record, or individual field or data. Okay. So there are different levels at which you can implement locks to different resources or database objects. To minimize the effort on locking, SQL Server automatically locks resources at a level appropriate to the transaction, e.g., row level or data page level. You recall from one of the earlier chapters when we were looking at which chapter is it? When we looked at this, I need to remember. I did look at I don't remember the chapter where we discovered this. Chapter 4. We had looked at pages in SQL. I think it was on indexes. Okay. We said that in SQL Server, it deals with data and groups the data in form of pages. Okay, so when it retrieves data from a table, particularly for the big tables, that is going to be broken up into multiple pages, what are called pages, sections, if you want. Okay, so at all these stages, you can implement logs so that where they are most appropriate. Now remember, SQL Server does this automatically. It will look at the transaction, the statements that is executing, and determine what will be the most appropriate level at which the log should be implemented. For transaction to access resources, SQL Server resolves a conflict between the concurrent transactions by using log modes. So because of the need to implement logs, there will be cases where there will be conflict. This user is trying to make changes to this same data, which another user is trying to modify. Those are conflicts. And SQL Server who has a number of mechanisms for resolving such conflicts. There are a number of log modes which are supported in SQL Server. The shared logs, exclusive logs, update logs, intent logs, schema logs, bulk update logs. I'll quickly run through this. The first one, shared logs. Shared logs allow concurrent transactions to read a resource. If there are any shared logs on a resource, no other transaction can modify the data on that resource. The shared logs releases the resource after the data has been read by the current transaction. Okay. Even before the data is committed, but once it has been read, what I mean is this. When the transaction starts, maybe the first part starts with a select statement. It will read data from the table or tables. During the time that it's reading, another transaction will not be allowed to access it. But once it has read the data, and maybe it has proceeded to use that data for updating. Once it has finished reading the data from the table, another transaction can access the table now and maybe insert a new row before the transaction concludes. Okay. The second type, the second mode is update logs. An update log sorry, I've skipped one, the exclusive. This one is exclusive actually. Okay, an exclusive log or exclusive logs, they do not allow concurrent transaction to read a resource. Okay. If there are any shared logs on a resource, the other transaction will not be allowed to have access to those resources. For shared logs, once a statement has been, the data has been accessed in a given resource, then other transaction can access it. But for exclusive locks, it means that the transaction which started is going to have exclusive access until the data has been committed or the data has been reversed, rolled back. Okay. Now, the update locks are like a compromise. They have features of shared locks and exclusive locks. For example, to update all the products with a price more than $10, you can run an update statement on the table. To determine the records that need to be updated, the query will acquire a shared lock on the table. When a physical update occurs, that is when data is now being committed to a table, the query acquires an exclusive lock. In other words, when the data is being committed to the table, being saved in the table, at that point, it will not allow other transaction to read or update or access that data. Yeah. In the time gap between the shared and exclusive locks, any other transaction might change the data that you are going to update. Therefore, an update lock can be acquired. Intent locks. An intent lock indicates that the SQL Server wants to acquire a shared or exclusive lock on some of the resources in the lower hierarchy. For example, when a shared intent lock is implemented at the table level, a transaction can safely acquire the intent locks at the table level. A transaction will place shared locks on pages or rows within that table. As the name indicates, intent means you're planning to do something. So when the transaction is going to need certain resources and you have enabled intent locks, it's going to indicate to SQL Server that it will need to allow that transaction to gain access to some of the resources which are at that level or lower than the level where you're implementing. Table, if it's a table, then from the table going downwards. Okay. SQL Server examines the intent locks only at the table level to determine if a transaction can safely acquire a lock on that table. Intent locks with their diversified features include the following: intent shared. That is when the transaction needs to have shared access to some of the resources. Intent exclusive, IX. That is when the transaction will need to gain exclusive access to a resource. Shared with intent exclusive means the resource is going to have the features of both shared and exclusive logs, meaning it's able to change from the transaction depending on the statement being executed, can change from shared log to exclusive log. For example, when it's executing a select statement, that can allow a shared log. But immediately you are doing an update, that can be changed to an exclusive log, in which case other transactions will not be able to access that resource. Schema logs. A schema log is used when a schema-dependent operation is performed on a table. What is a schema? We seem to come across this term quite often. What is a schema in the context of databases? How do you describe this schema? Yes?
I think it is the retrostructure of the database.
You say?
The retrostructure of the database.
Okay. We say that the schema is a logical grouping of objects in the database. Okay. The idea is objects that need to be given, maybe where permission need to be given to one group of people, can be put in one schema. So if you have designed a database, you may have certain tables where only people from accounts of finance department should have access. You might have tables where only people from production should have access, or where there should be limited access by people who are not part of that department. So the purpose of a schema is to allow for permissions to be given to different groups which will need to access the objects according to their requirements. Some will have full access, some will have only read access, others will have maybe modify access, and so on. Okay. So whenever you come across the term schema, immediately what should come to mind is we are dealing with a data definition language. We are dealing with the actual objects in a database. SQL Server considers schema modification logs when any DDL operation is performed on a table. This could be altering the table, adding additional columns, adding a constraint, changing the data type of a given column, and so on, or deleting the table altogether. Okay. That is, SQL Server will consider the schema modification logs at that point. But if the processes are data manipulation language statements, operations, then it will not consider the schema logs. The last type of logs is called bulk logs. A bulk update logs. A bulk update log ensures your table secures your table from any other normal SQL statement. It could be data manipulation, or data definition. It will protect your objects from any of them, except multiple bulk insert statements or a bulk copy program can be performed at the same time. How should logs be controlled? Okay. Logs are implemented automatically in SQL Server, so in most cases, you don't need to make any changes. By default, SQL Server logs every row that you query at the time that you are querying it. To resolve problems associated with logs, you need to use isolation levels. You can use isolation levels to specify the rights other transactions will have on the data being modified by a transaction. The following types of isolation levels are supported in SQL Server. The first one is read and committed. Read committed, repeatable read, snapshot, and serialized. Let me quickly look at each of these. Read and committed. This specifies that a transaction can read the data modified by the current transaction, but the modifications have not yet been committed. What I mean is, for example, you want to maybe update some records. When the first step will be to read data from the table, which meets the condition that you have, the criteria that you have set. And once those have been found, then the values are going to be now changed to what you have set. Okay. Now, what we're saying is that before those changes have been saved back into the table, you can still access them. The other transactions can still access those changes before they are saved into the table. Database objects are also not blocked by the exclusive logs, enabling other transactions to read the data being modified, but not committed by the current transaction. The transaction can read uncommitted data, resulting in dirty read problem, where it reads data, but then when the data is saved, something has changed. Okay. This is the least safe isolation level. It's the least secure isolation level. The second one is read committed data. Read committed specifies that a transaction cannot read the data modified by the current transaction. This prevents the problem of dirty read. This isolation level places an exclusive log on each update statement in the current transaction. Exclusive log means that no other transaction will be able to access that piece of information until that statement has been completed. Other transactions can update the data that has been read by the current transaction. This is the difference. And this is, I think, the case we had when I was illustrating that. The first time the table had no data, so we used an insert statement, but before we could commit it, we tried to use another transaction to access that data. But because it was locked, the second transaction kept pending, waiting. But after that, after executing those transactions and committing the changes, the next one, what happened was the first transaction was adding an additional row to the table. So when we started another transaction, the transaction was only able to show us the information that was there before, which was committed in the previous attempt. Okay. This results in a problem of phantom read. So, because data has been read, maybe it's a delete statement. Once it is read, before the delete is now committed, another transaction can read that data. But once the first transaction has committed, that data is going to be deleted. So when the second transaction tries to read again, it will not find the data. Okay. This is the default isolation level in SQL Server. So unless you specify a different type of isolation level, this is the one which is set, which is going to be used. Okay. It's more secure than read and committed, but it's also not very secure. In other words, it's somewhat of a good compromise, because remember, the isolation has an impact on the performance of the database. In other words, when you use certain types of isolation, that data is not going to be available to other transactions. And that can lead to delays. So you see your system delaying, waiting, and depending on the number of users, the traffic that can be significant. Okay. So Microsoft tries to find a good compromise. So the default isolation mode is read committed. It doesn't completely remove any access to the data, but it restricts. Repeatable read. By looking at the types of isolation modes, we have looked at read uncommitted, read committed. The third one is repeatable read. This specifies that a transaction cannot read the data that is being modified by the current transaction. Also, No other transaction can update the data that has been read by the current transaction until the current transaction completes. I don't know if you are seeing the difference between that one and this one. In read committed, we're saying specify that a transaction cannot read the data modified by the current transaction. This prevents the problem of dirty read. This isolation places an exclusive lock on each update statement in the current transaction. So other transaction can update data that has been read by the current transaction. This is the difference between this one and this one. No other transaction can update data that has been read by the current transaction until the transaction completes, either is committed or it is reversed or rolled back. Also, it places a shared lock on each select statement. When this isolation level is set, other transaction can insert new rows which result in a phantom read. Okay. So here we're saying the other transaction cannot access the data that was read. But if another transaction try to add additional rows, it can do that before the first transaction completes or commits. It cannot just access the data that was accessed. I don't know if that is making sense. What I mean is this. We have, let's talk about the banking system application. We have a transaction which we want to see how many bank accounts have balances lower than the minimum required. And we retrieve maybe 10. Now, in repeatable read, it means that those 10 accounts cannot be accessed by other transactions. But if another account which had more money, but has not had more money when we were reading, executing the select statement, has performed the transaction, and now the minimum, the balance is below the minimum, that can be added to the table. We are saying other transaction can insert new rows as long as those are not part of what was read by the first transaction. And because of that, you can have the phantom read where the first transaction commits and you try to check the results, you find that you have additional information because while that first transaction was being executed, additional rows were inserted. Okay. The next lock mechanism, isolation mechanism, is a snapshot. So We're looking at the isolation levels or isolation modes. We have looked at read uncommitted, read committed, repeatable read. Now we are on snapshot. Snapshot provides every transaction with a snapshot of the current data. Every transaction works and makes changes on its own copy of the data. So what happens is that when the transactions are being executed, they take, maybe they are retrieving data or accessing data in two tables. Each of the transaction involved is going to take a copy of the data as it is in those tables at that particular time. And it will start work, each transaction will be working with what data it has copied while leaving the original data in the table. When a transaction is ready to update the changes, to commit the changes, it checks whether the data has been modified since the time it started working on the data. And if that has happened, it will decide whether to update the data or not. To be able to use snapshot isolation, you need to use this statement. Allow snapshot isolation, you set it on. Okay. The allow snapshot isolation data option must be set to on before you can start a transaction that uses snapshot isolation level. If a transaction using the snapshot isolation level accesses data in multiple databases, the allow snapshot isolation must be set on in each database. Okay. So this is a case where you are doing data stored in more than one database. In such a case, definitely this must be set on. Serializable isolation level specify that no transaction can read, modify, or insert new data while data is being read or updated by the current transaction. This is coming from serial, meaning they have to be done in sequence, one after the other. This is the safest isolation level provided by SQL Server, as it places a lock on each statement of the transaction. Remember, the others that we have looked at will allow access to data in certain instances, but this one blocks access to the data until the transaction has been completed. In this level, the concurrence is at the lowest. In other words, the execution of transaction is at the lowest level because all the transactions are going to be executed in sequence, one after the other. They will have to wait for one transaction to be completed before the next transaction can be executed. The other options we have looked at might allow some transactions to be executed concurrently. For example, snapshot, we are saying one transaction each transaction will copy the data and begin to work with that data that it has. So you can have two transactions. They copy the data from the same table, and then they start working with that simultaneously. The only requirement is before committing the changes to the table, you have to check to see whether the data in the table has been changed since it was copied first. And because of this, we are saying this will offer the least performance of the database system, but it's the most secure. Okay. Now, how do you implement isolation labels? Remember, we're saying that logs are automatically implemented, but you can implement them at certain levels where you feel you need to change from the default or to be the one deciding. Because SQL Server, in its default setting, will be deciding what's the best way to log the data. Okay. And in certain cases, the results may not be what you are expecting. So for those particular cases, you can set the transaction isolation label. And to do that, you use the set transaction isolation label statement. So that's the syntax. Set transaction isolation label. And here you have a number of options, which we have just been looking at. Read and committed. Can have read committed, repeatable, read, snapshot, and serializable options. Can have one of these options. Of course, that ends the statement, so you have the option of putting the semicolon. Then you begin the transaction. Once the transaction has been concluded, you can commit the data. Okay, so that's the syntax. Okay, I have a few examples which I want to show you. This is the first one. Again, let me just explain what is going on. This, we set the transaction level, transaction isolation level to read committed. And then we begin the transaction, which we name, we give the name TR. Then we use try, so that in the event that an error is generated here, we should skip everything else and go to where it says begin catch. Okay, and that's okay. So once we have begun the transaction, we want to update the contact details. There's a table called contact, and the schema is called person. Now, in this table called contact, we want to set the email address to that value. For a contact where the contact ID is 1070. Once we do that, we want to update the table called employee address in the human resources schema, where we are going to set the address ID to be equal to 32,533. We're going to set the address to this value for the employee ID one. Okay. And we'll commit the transaction there. Okay, so that's the first example. The second example is this one. It has a lot of go because we're trying to break into a number of batches. Remember, the word go is just used to indicate the end of a batch. So the first part is to set the transaction isolation level to repeatable read. In the previous example, we used read committed. This one, we set it to repeatable read. Then we begin the transaction where we perform select. Okay. We perform this statement where we retrieve data from this table. Originally, this was human resource employee paste. I need to change this. And this one is human resources department. Okay. So this okay, I'll illustrate. But basically what I'm doing here is I have a table called employee pay history. I select all the data from it. Then I update this table where there's a column called rate. I've set every value to 25 because I haven't put a condition. Remember, when you use update without the where clause, then it's going to update all of them. Once I do that, then I want to select and show the departments. Then I commit the results. Okay, so let me go to the management studio and show you what I'm talking about. Okay, so I have this so I start by setting the isolation level to read commit and begin the transaction. The employee and so on. Okay. Because I had done, when I began, I used try. I need to have a corresponding begin catch, this one, so that if an error occurs somewhere here, then execution will skip from that point to this part, to execute this part, to say transaction rollback. Okay. Now, I want to just confirm something. I want to check this data. First, let me just check if there is a contact with this address. So I'll say select. Select. I want to see everything. Person. I say schema, contact. Where contact ID is 1070. So contact ID. So let me put this as a condition that you can check out this contact is there. So there is this contact, and the email address is jolly0@adventure-works.com. Okay, so that would work. Then the second part, the update, is we want to update the address and set to that where employee ID is 1. So again, I want to check in this table. Checking table values. So this one is select from human resources address. Okay. So we have that. Okay. The employee ID is that one. Okay. So if this transaction is successful, this should be the new address in the other table, and the address ID should be that. Okay. So I will go ahead and execute this statement. So we are told in one of them that one row has been affected. Then we have 0 rows affected in the other. And we have the statement telling us that transaction rollback. Okay. So something went wrong, and so the transaction could not be completed. Most likely the dependence, the foreign key, because if you look at this data, if you look at this is a table with a foreign key. The address ID is a foreign key in this table. So if this does not appear in the primary key, then the transaction is going to fail. And that's why it's reversing the transaction. Because we have set the transaction isolation level to read commit. So if another person tried to make some changes before we reach this part, commit the transaction, then the SQL Server is going to prevent them from updating the data that is being dated. It's trying to update. The second example on how you can set the transaction isolation level is this one. Okay, so what I'm going to do is I'm going to copy data from the table so that I don't affect the other table into new tables, and then I'll do that. So I'll use that statement. I hope that is familiar. I'm copying all the data from this table called departments into another table which I'm calling temp departs. So that the result will be an additional table with the same data which we can play with. We can still use this. We can still use this one. Okay, so we'll just use this one. So we need to understand what is going to happen here. We are setting the isolation level to repeatable read, and then we begin the transaction. And the transaction means selecting data from this table, and then we're going to update all the employees. Okay, this is the reason why I didn't want to. Okay, let's see this, then we can execute it. And it's going to destroy the data. I didn't want that. No, let me not. Okay, if I execute that, what is going to happen is I have, this is the department, okay? Then there is also this one. You see the pay rate, there are different values. So I'm going to update all of them. Let me just update for one of them so that I can easily reverse. I'll say employee ID. where is the process that employee history dot ID is equal to okay, 5. Okay. So we execute that, and then we can check this table for employee number 5. Okay, that's right. Let's check the messages. So 316 rows affected, 1 row affected, 16 rows affected. So let's see what has happened. In this one, there's 5. Employee ID equal to 5. Why do I have 26 instead of 25? Six instead of 5. Then the other one, let me just see where they are 6, 316 rows. Okay, so this transaction has been executed, and in the process, we have set this isolation mode to that. Okay. I hope my future examples will not be affected by the difference in that. Okay. So that's how you set the isolation transaction isolation mode. Okay. I need to conclude this. Okay, I'll quickly go through this, and there is what is called deadlocks. Okay. A deadlock is a situation where 2 or more transactions have locks on separate objects, and each transaction waits for a lock on the other object to be released. I don't know if you can see this illustration. What it is that transaction A has placed a lock on distributor table, and transaction B has placed a lock on products. But for transaction A to complete its executing its processes, it needs to have access to this table called products. So it's going to be waiting for transaction B to finish the execution. But transaction B also will not complete its task because it needs to access the distributor table, which is locked by transaction A. So in that sense, there is like a stalemate. That's called a deadlock. Okay. And these two transactions are not going to complete. They're just going to remain like that unless something is done about them. So a deadlock is a situation where two or more transactions have locks on separate objects, and each transaction waits for a lock on the other object to be released. Deadlocks are dangerous because they decrease the concurrency, that is, the number of transactions that can be executed concurrently at the same time, and also availability of database and database objects. Because as long as transaction B is still waiting for transaction A to release the lock on distributor, it will just remain like that while products table is locked. So no other table will have access to products table until transaction B has been completed. And because it cannot complete, it's also waiting for transaction A, then you have a situation where transactions are like in a kind of stalemate. So to resolve these deadlocks, you can resolve deadlocks by using one of these methods: setting deadlock priority, customizing the lock timeout. Priority, you set which, okay. The third way you can resolve deadlocks is detecting deadlocks. And the fourth one is avoiding deadlocks by using update locks. Priority, you use this statement to set a priority, and the priority can be set to low, normal, or you use a variable for the deadlock. If you set the priority to low, it means that that transaction or that session, when there is a deadlock, that's the one which is going to be terminated, not the other. So it's going to be the deadlock victim. If you set it to normal, it means that it will wait for the other transaction to be terminated. The second way is to set the timeout, lock timeout. When a transaction attempts to lock a resource, which is already held by another transaction, SQL Server informs the transaction of the current availability status of the resource. If the resource is locked, the first transaction is blocked, waiting for the resource. So once that time has elapsed, then the resource will be available, and so it will execute. That is, this is in the event that there is a deadlock. One transaction has put a lock on maybe a table this side, but it also needs to use another table, which is also locked by another transaction, which is also waiting for this one to release this table so that it can use it. And this is the syntax. You set lock timeout, then you indicate the number of the time in milliseconds. Detecting deadlocks. SQL Server scans for the sessions that are waiting for a lock request. With the intelligent use of a deadlock scan for sessions, SQL Server ends a deadlock by automatically selecting the user who can break the deadlock as a deadlock victim. That is the one who has set the level to low priority. Okay. So it's going to do that automatically, but it's going to look at which user has been set to low priority. The other way you can resolve deadlocks is to use, what is this? This is the system view. We looked at views. This is the view which is pre-created in SQL Server. And you can access it by running this statement. Okay. To see the status of the different transactions. Let's see. Okay, this is the one. So it's going to show you a lot of information about the sessions. Session 1, request ID, time, status, background, command, SQL handle, statement, start, offset, and so on, all that information. So you can use this view to look at the status of the different sessions, and you can then decide on which one you need to sacrifice to complete your transactions, or where there's a deadlock. The last one is to avoid deadlocks by using update locks. When two concurrent transactions acquire shared mode locks on a resource and then attempt to update the data concurrently, one transaction attempts conversion of the lock to an exclusive lock. In this scenario, the conversion from the shared mode to an exclusive lock must wait. This is because the exclusive lock for one transaction is not compatible with the shared mode lock of the other transaction. Okay. So these are the ways in which deadlocks are resolved. Setting deadlock priority, customizing lock timeout, detecting deadlocks, and avoiding deadlocks by using update locks. Okay, a few questions. Just two questions. Which of the following locks is applied by transaction? Which of the following locks, if applied by a transaction, will allow other users to view the data being modified by the current transaction? Shared locks, exclusive lock, update lock, intent lock. So shared lock. What do I say? It's shared lock. You can go through elimination, look at intent, what we said about intent, update lock will implement an exclusive lock. Another question, Which one of the following statements is used to undo changes made by a transaction? This is best. Yes. Rollback transaction. Okay. I'll share this on the then I can use that for revision. Any questions? We need to, because it's almost 20 hours, so I've taken longer than